Welcome to Entonal Sessions. I've got Hector with me again today.
Hi.
And what I want to go through today is just some real basics in terms of tuning, some like core fundamental concepts that are important to understand, to get to know the language that's used in a lot of tuning software and when talking about scales and the intervals within them. So let's go. So I've got Ableton Live here, and I've got Entonal Studio loaded within it. This is the instrument version of Entonal Studio, just for simplicity, so we don't have to do any routing. We're using the internal synth that comes with Entonal Studio. It's called Simple Synth. What I've got here is a blank canvas. So I've just created a new empty scale. So what we're here to talk about is what are the fundamental building blocks of scales using Entonal or any other tuning software. And also when you're talking about or reading about different tunings, there's a language. And the language, the words of that language, if you like, are quite mathematical.
Right.
And scales are described either in terms of sense, which you may have heard of, or ratios. So you might, if you're a music producer, you might have come across the term sense. So what is a cent? Do you know?
It's
do you understand?
100 of a semitone.
Yes, exactly. So yeah, the word cent gives it away.
Yeah.
So I'm going to talk about cents, and to start with, I'm going to start with the 12-tone equal temperament scale, the standard scale, and Entonal has got this notation that makes it easy to describe scales that are divided into different equal divisions, as they're called in the octave. But we're not going to dive into that now. But what I want to show you is we've got a 0 cents here. This is the root. And then this we can write as 100 cents. And you can see I'm adding a C that tells it that we're talking about cents.
Mm-hmm.
200, 300. Now,
It's 100% necessary to add the C, otherwise the internal wouldn't understand it as a cent, right?
Exactly.
Okay.
That's very important.
Yeah.
If you just put a number in, it interprets it as a number which is linked to how the ratios are interpreted. I'll talk about that in a little bit.
Yeah, sure.
So we can go 400, etc., going up. And now what we can do is we can play around with this number. And so we could go to, say, 150 cents, which is half of a semitone.
Yeah.
So these are semitones. So let's compare that to 100. Now, if we put that back to 150, you can see now that's a bigger interval there.
Yes.
Between the C and the C sharp.
Mm-hmm.
And actually, that 150 cents is quite similar to, we've got an Arabic scale here, or something that's, inspired by Arabic music, which has this 150 cents, which is like, some people talk about quarter tones or have written about Arabic music in terms of being constructed with quarter tones, which I now understand is quite an oversimplification.
Right.
It's more fine-grained than that. So it's interesting. This Arabic scale has, the first interval is almost 150 cents. Just that little phrase has an Arabic feel to it, right?
Totally, yeah.
Did you have a question about
I was
that sense?
There's one thing I noticed in that, obviously, as you approach the number 12, it goes over 1,000. How does that, I mean, what's the limit on the cents? Because I thought, like, if it goes back round, it should be like from 0 to 1,000, and 1,000 which should be just like we complete the circle. Is that making sense?
No, a cent is because you've got 1 cent, so 1 semitone. We put this. If we put this to 100, that's 1. Okay, so it gets confusing because we talk about whole tones and semitones.
Yeah.
But in this sense, like cents describe one. So a cent is 1 semitone divided by 100.
Yeah.
Right? 1 semitone.
Yeah.
There are 12 semitones in 1 octave.
Oh, fair enough. So
that's why
yeah, makes
when
sense
you get
now.
to the top, actually, so that is lower. Normally, the normal, so that.
So what happens if you put that as...
So that would normally be 1100. That's standard. That's the equal
I see.
temperament.
So if you put it to like 1200, that would send it back to the root, shouldn't it? Or am I getting confused?
Yeah.
Yeah, you should, right?
If you put that as 1200, it would overlap.
Fair enough. Yeah, that makes perfect sense now. Yeah, that's what I was trying to.
So that goes. Yeah, it's like it's like a circle. It goes round again.
Yeah, because it's 12 notes. Yes,
Yeah.
of course.
Yeah.
Yeah, if you add more notes, if you create like a scale that has 15,
Yeah, we can add more notes.
will the sense still remain the same? The ratio of sense will still.
What do you mean? So I can. So with just to compare, I can add another note and it reorganizes everything. So now we've got a 12 tone semitone and we've got that.
I understand it. Okay, so I understand it. So we're still playing with the ratio of.
It's not.
Zero
This isn't.
to 12.
So this isn't ratios. This is sense.
The sense, yeah,
Yeah.
from 0 to 12, and then
Yeah.
what we're doing is we're doing subdivisions within those boundaries, if that makes sense, right?
Exactly. Yeah.
Okay.
So like, if you like, in terms of if you're thinking about the octave, you have 1200 tiny little divisions
Yeah.
of the octave when you're constructing a scale this way.
Makes sense. Yeah, I understand it now. It's a very interesting way of doing it. So just basically subdividing, but you still are working within that
Yeah.
particular range. Yeah.
Yeah. I mean, you can also. This number down here describes how big your octave is. Your octave doesn't have to be the standard 1 octave, which is 1200 1200 cents. Right?
Interesting. Okay.
This could be. It could be. There are some scales that are like based on 1800 cents.
So we like breaking away completely from the standard.
So then you can have a new interval here at 1200, and it doesn't overlap the one.
I get it.
Get it?
Totally. Yeah.
And you can keep going up. You could divide it into, the equivalent of 2 octaves, if you want.
That's really cool.
And then you can have like almost like it's almost like stacking 2 different scales, one on top of the other.
Pretty much, yeah. Sounds really cool. I like that.
Yeah.
Very interesting. So you can break away from that. Oh, really interesting. And you can make it like any number, I suppose. You could do like 1800 cents being the maximum length as well, for example.
Yeah.
So it's like 100% customizable.
Completely. Yeah.
Wow.
Okay. So should we move on to ratios?
Mm-hmm.
Do you wanna? Yeah. So. Okay, let's start. So now I'm gonna start again now. Gonna create a new empty scale. I'm gonna start again. So now I've got a blank canvas. And usually, okay, so let's talk about ratios. So ratios are a different way of describing an interval in a scale. When I talk about an interval in a scale, so here the scale only has 1 note. one note per oct. It's just one note.
I like
It's just
it.
one note. Yeah, it's cool. Yeah, it's got one note per octave, nothing else. And we can describe that as the root of that is 1, or 1 over 1 when you're talking about ratios.
Mm-hmm.
Now let's get into the other ratio. So the most sort of common and easy to understand, easy to describe ratio is 3 over 2. So let's write that in. Why 3 over 2? Well, 3 over 2 is the same as 1.5. See, they're equivalent. And this relates to our mapping. Okay, so let's have a look at the mapping now. So we've got root note A. So we're starting at the A.
Mm-hmm.
Right? So that's the A. And yeah, the root note is A, the root frequency is 440 hertz. Let's see what that means. So we've got a table here. Let's scroll to the starting point.
A3,
We'll get
right?
there, yeah.
Normally on a keyboard,
Thank you.
middle C. Yeah.
Thank you. So A3. Look, we're starting on A3. So we're going up and down from the A3. Right? So A is 440, so 440 is usually, that's the concert A frequency. Let's remove this 1.5, go back to just 1.
Oh, and it's double.
We've only got 1, and now you can see, if you look at the numbers here, let's start with 440, you can see as it goes down, it's just halving again. And as it goes up, it's doubling and doubling again.
So it's jumping octaves.
This is what our scale is. Oop.
So each note is literally jumping ahead 1 octave, which is what we had before.
Exactly. Yeah. So let's add that 1.5. I'm going to call it 3 over 2 because it's usually described as a ratio.
Right.
So 3 over 2 is 1.5. So now we've added this interval 3 over 2 into our scale. It's what's often described as a perfect fifth.
Okay.
Let's compare this now. So I'm gonna load up. I'm gonna switch to the equal temperament scale, and you'll see that if I play, that's the C and the G. The G is fifth above C.
Yeah.
And if I undo that scale change, we can see the 3 over 2 is where that G was.
Okay.
Okay? So it's the fifth. Also, but it's the perfect fifth. It's the just fifth. Let's move that. So let's go back to our table to understand this a bit better. Let's look at the numbers, okay? So I've got 440. And then the next one, before it was jumping to 880, the octave above. Now we've got something right in between, not exactly in the middle, and that is the fifth. And the fifth is like related in thinking about harmonics, which was in the last video we did. It's the third harmonic.
Right.
The second, no, it's the second harmonic, isn't it?
I can't remember on top of my head.
Yeah,
we can look it up. It's got to be.
I believe it's the
fundamental first, second.
It's the first is the octave.
Yeah. Second. So
and
you're going on.
Third is an octave and a perfect fifth above the fundamental.
Yeah, I can visualize that. Yeah.
So when we say fundamental, we mean the root, which we've given as 440 here. So that's the perfect fifth.
So what we're doing with the ratio is if we go, So if you don't mind me asking, I know
Please ask
it might
away.
be like a very silly question.
No,
but
there's no silly questions.
if you go back to the table thingy.
Yeah.
So you got like A being 440. So what we're doing is multiplying 440 times 3 divided by 2. Is that how we get the 660? Okay.
Or, well, it might be easier to think of as what's the result of 3 over 2 is 1.5.
Right.
So that will give us the same numbers. So you got 440 times 1.5. Yeah, so we go 440 times 1.5 equals 660. And then the next level is, because we've jumped the octave, everything is divided by 2. So here, the actual ratio. So this column is useful because it shows you exactly the number. It's like root times this number equals this number.
Oh, I see. Okay.
So if you go, so you can see, so going from 1 upwards, the next one is 1.5, then the next one is 2 because it's the octave, it's doubled. That's 2 over 1, which we've got here. And then 2 times 1.5 is 3, and then doubled again is 4, and then 4 times 1.5 is 6. You just keep going, just keeps going on like that.
Makes sense.
That's a really brief introduction into ratios.
It makes sense now, though.
I'm just going to wrap this up now by adding a few more intervals, some common intervals. We can go into these different intervals in another video. So yeah, I'm going to wrap this up with another interval, which is the major third here. And just an interesting thing, if we show the harmonics, you can see in terms of harmonics, we've got, that's the first one, technically it's the second harmonic, it's the first one that's not,
that was the perfect fifth.
It's not a repeat of the period, which is where the octave is repeating. So yeah, we've got 3 over 2, 5 over 4. You can see here, if I put the snapping on, change that to 5. Yeah, you can see, yeah. So there's our perfect major chord. Gonna wrap it up there.
Nice one. Thank you so much for sharing.
Yeah, pleasure. So that wraps it up. Thanks for watching. Thanks for being here, Hector.
Thanks, Adam. No worries, man.
Till next time.
Take care, everyone.